Hello everyone, thank you for being here with us. Very happy to be here talking about Kinect SDK beta launch. Now this session we're going to be talking more about user experience and design. Thank you very much again for joining us. This is going to be the session called Designing for the Body. My name is Arturo Toledo. I am a designer here in Microsoft, and I'm here with my friend Ali Basai.
Hello, nice to meet you. I'm a senior user interaction designer with Xbox.
And we're very happy. We're going to go right into the session. We have really just a little bit of time to cover a lot of information. Just remember that these sessions are being recorded, and so you can always go back and check it out because we're just going to be giving you a lot of information. Here's a little bit of the outline of the topics that we're going to be covering today. We first are going to start by having a UX conversation. The way that I like to describe it is sort of like the design theory portion of the session, about 7 minutes. Then we're going to jump to Ali, and he's going to be talking to us more about interaction design for Kinect, especially paying particular attention to gestures. Then we're going to be talking about test and research, as well as prototyping for gestures, and we're finally going to close with a Q&A session. So this session is really aimed at experienced designers, but developers as well, because as we all know, when it comes to Kinect, it's really teamwork and team collaboration where you get the creative people, the technical people all together working on a single thing. So let's start with the first topic of this part of kind of conversation with Ali here. What is the impact of Kinect for me as an experienced designer? And so here's the thing about Kinect. Kinect is really an input mechanism, right? And for many years, we all, as experienced designers or developers, we've created experiences that deal with a mouse or with a keyboard type of input. Now, Kinect brings, a different type of approach to how we create experiences because it adds a lot of different dimensions and layers of input data. One of the ways that our friend John Davis, also in Ali's team, likes to show this is, right now if I asked all of you who are watching the show to click your left mouse, to hit the left button in your mouse, all those clicks of these 350 million people that are watching us right now will be the same click, right? We're all clicking the very same button. It's one single gesture. Now, let's translate that into Kinect, and now let's pretend that we want to capture that same click with a wave gesture. So everyone go ahead and wave at us. We promise you we're going to be able to see you somehow, right? So everyone is waving differently. I can assure you some people are waving like this, others like this. Some people are sitting down and they were just kind of like that. So everyone is doing a different waving gesture. So the complexity of Kinect comes a little bit with that in understanding and unifying all those different gestures that came into the system, but for you then to interpret them as a same single command that the users were trying to do. A little bit of this has to do with recognizing intent for gestures.
That's right. Yeah, and that's the tough part, right? So imagine all the different waves. You couldn't see each other, but trust us, everybody waves differently. How is the system going to understand when you meant to wave and recognize that movement versus when you didn't mean to wave and maybe you just brought your hand up to scratch your head, for example?
Exactly. So that's kind of the tricky part there, and we have to, as experienced designers or developers, consider that we're dealing with a different type of input mechanism. It really, truly is the human body. Right. Bill Buxton has an interesting quote about this particular slide.
So, there's a tendency out there to think of Kinect as a panacea, that if you were to simply just use it, that you could use it for everything. And that's really not the case. It's not really meant to replace all the other forms of input: mouse, keyboard, controller, pen, stylus, etc. As Bill Buxton would say, right, that everything is best at something and worse at something else. And so, just keep that in mind. You don't have to solve all your interaction design challenges with Kinect and with air gestures.
Exactly. So let's go to the second topic. So where and when does the magic truly occur when creating Kinect-based experiences? I'm sure we've all seen all these different applications, or we've played games on Xbox, and Kinect just feels pretty magical when you connect to software or user interfaces in a very different way in which we've done in the past. And there is that moment of like, wow, like, the moment of coolness. So what would be a couple ideas for us to share with you to create more of those magical moments. And the way that I like to explain it is by understanding this concept of semantic data, which is data that has relation to other data. So what Kinect really does, the magic that it does, is that it captures your body, but it's no longer, your body is no longer just a flat collection of pixels as we've had in photography or video for many years. Now Kinect adds other layers of information on top of that data. So now your body's still pixels because we have a video camera, but now we also have things like depth tracking, skeletal motion as well, joints, voice recognition, and so you have all these input ways that add layers of information. What that does is that turns your body into something we call semantic data. Data that has relations and that tells us more about the body itself. And then the magic occurs really when you guys, all of you guys that are watching us, you come up with creative ideas, creative ways to transform that semantic data into something completely different. Could be an avatar, like the one we have on the screen right now, right? So you're literally converting the human body into an avatar. You can make it look any way you want.
That's right.
But if you, I'm a fan of Nathan Sawaya's art. I don't know if you have seen him doing this amazing art. He does not use Kinect. Yeah. That's precisely the amazing artistic talent that he has to create these Lego sculptures. I'm sure we've all seen this by now. Well, that would be a challenge that I would give you guys. If you were to take the semantic data from human bodies, how would you then transform it into something like Lego pieces? Or something as crazy as M&Ms. How would you transform that semantic data into a group of M&Ms that maybe, you know, are the colors are selected based on your body, and then you can take those home and eat them. Or you can also perhaps transform your body into light strokes on the air, or perhaps you use some type of laser device to express your body in different ways. So again, the creativity relies on your ability to come up with ingenious ideas to transform that semantic data into something completely different.
That's cool.
The final topic here is, what are some of the most common ways that designers and developers are using Kinect as an input mechanism? And here we're going to talk more to Ali about this one, because he's had a lot of experience learning and discovering the potential of Kinect. But a couple of the interaction metaphors that we want to talk about are cursor or avatar. These are two different ways. Right. And as Ali was actually helping me understand right before the session, in fact, is that it really depends on the task that you are asking users to do to know when you want to rely on one or the other, right?
Yes, that's right. So you can think of it as cursor or avatar, but in truth, really what it is, it's about whether you want to really track the person's hands or track their full body. And of course, the decision you make is really based on what it is you're asking your users to actually do. And so there's plenty of examples. We've seen some earlier today, and I'm sure that's not the end of it. People's imaginations will go quite far.
Absolutely.
There are plenty of examples where, let's say, for example, if the task was to, you had a UI where there were lots of targets on screen that people had to basically interact with, then you might be interested in just targeting the hands, where do hand tracking, where as I move my hand, I can actually target the individual objects. Contrast that with if I was tracking the entire body, then you could almost imagine that we're going to take that body, put it into the UI, and I know you've got some screenshot examples of that, where then the person literally has to move around within a given environment or space, right? The system's going to translate their physical movements in the real world to movements in virtual space, right? And and then I would look at myself, much like a weatherman might do on TV, right?
Yeah.
They might move over here and point to something. They might have to move over here and point to something. So it could be full body. They might have to move forward or move back. So which one you do really depends on the task.
It's really all about that. And at the end, one of the things that we've all learned here is that Kinect still requires you to continue to design for the user, right? It's still a user design process.
Absolutely. Don't design for Kinect, design for the user.
Exactly.
Yep.
That's a quote right there. Then another concept that I was talking to Ali about is the shadow effect and the mirroring effect. So can you tell us more about that?
Sure. So think about, like, when you want to do the full body tracking, you have to ask yourself, how do you want to represent the user on screen in that virtual space? do you want, when I stand in front of Kinect, do I want to see a mirror image of myself, right? And if it's a mirror image of myself, I'm immersed into the UI. And of course, if I'm interacting with the UI, moving my hands up, down, left, right, moving my body left or right, not a problem. Where we see problems with mirroring is in Z. So if I'm seeing an avatar or a version of me on screen and it's a mirror duplicate of me, then movement in Z, people tend to make some mistakes. They look at their avatar on screen, and then when they want to move forward or move back, they tend to flip it and get it wrong. Now, it's a little bit hard to describe abstractly, but contrast that with the shadow, right? So in this example, what you're showing here, I'm standing here, and if I were looking at the screen and I see my avatar, I'd actually be seeing the back of my avatar. So now when I want my avatar to move forward, I move forward. When I want my avatar to move back, I move back, right? And then there's left and right, which is usually not a problem. Contrast that, right, with
mirroring, for example.
If I want my avatar to move back, I tend to, your avatar is going to move into the TV screen, but instead of me moving forward, I have to move back. We have to move away from each other. And it's a little bit of a cognitive leap, a little bit of a mismatch in people's mapping, and that's why, once again, it depends on the task. If you want somebody to stand still, mirroring is fine. If you want them to actually move around, then shadowing is better.
Perfect. So that, again, talks more about the flexibility and the huge range of different interaction metaphors that you guys can use when creating Kinect-based experiences.
Right.
The final one, just to close this conversation, is the dialogue. And here a great example is Kinectimals, right? Where that was amazing experience the first time that I had a chance to use it. I am not the avatar. I'm not the tiger in this case. There are no buttons that I have to press. I'm literally establishing a dialogue. And that's what I've noticed a lot of the projects that people are putting together with Kinect these days do really well. They immediately hook up with the user by establishing this dialogue, which is created by the interaction that the element on the screen, in this case the tiger, allows you to have with. So different ways that people have to do interaction. Now let's really jump into how do we take a lot of these concepts for everyday life as designers, and let's learn more about interaction design. So I'm going to let you move over here, Ali,
okay. Yep.
So you can.
I'm going to step over here. So really what we're going to talk about here is designing, like the things that you need to take into consideration when designing for gestures, specifically for things like UIs, menus, dashboards, things like that. Myself and teammates of mine, John Davis, Eric Pennington, Christian Klein, and a whole host of others, we spent 2 years trying to work on various gesture interaction type designs for shipping version 1 of Kinect. And so there's a lot of things that we've learned, and we'd like to impart some of that and share that with you. So in doing that, I have this framework, this 2-part framework. And the first part is conceptualization. It's the types of things you might want to consider and think about as you figure out what types of gestures you might want to design for the particular task you're asking the user to do. And you can go broad and think pretty big, and then using some of these hints and tips that I've got for you, you can narrow in on your right candidate gestures. And then you can go into a prototyping and testing phase, which is the second diamond, and really finesse and polish and see if you can get it to work. So let's get started. One of the first things that I'd like to point out is this idea that when we talk about natural user interactions, if you notice when Kinect shipped, all of the title launch games were really built from scratch. They were built from the ground up. And that's evident in how immersive and how fun they are, because they really took advantage of Kinect's strengths. You didn't see games that were out there that existed already and tried to take NUI and superimpose or force-fit it on top of an existing game. In other words, there weren't games that were retrofitted for NUI. All of our title launch games were built from scratch, and consequently they're quite effective at using Kinect. On the other hand, we actually did go through an exercise for the Xbox dashboard where we said, hey, you know what, let's keep the UI the same and see if we can retrofit and force-fit NUI on top of that. Let's see if we can get gesture and speech to fit right on it. And of course, we refer to that as NUicide. Not a good idea to take an existing UI and force fit a new form of input on top of it. Not recommended at all. So the next point, think about your users' mindsets, right? So you're building something and for somebody to use, and you have to think about their mindset as they come to approach and use your particular solution. As a quick example of what I'm talking about, in a game environment, if I were playing, ping pong or something like that with Kinect Sports, if I went to actually swing the paddle and hit the ping pong ball, I might miss. And I would think to myself, well, gosh, this is a challenging game. Next time I'm going to try again, and next time I'll do it better. I'll try moving my arm a little faster or a little bit higher to put top spin on it. And that challenge is actually what makes the game fun. Now compare and contrast that to the user's mindset within a UI. If I were trying to move content from off-screen on-screen and there was a gesture that I needed to do to accomplish that task, if I did the gesture but it didn't work, chances are I am not thinking to myself, wow, this is going to be challenging. I love it. I'm going to do it a little bit better next time, and I'm going to master it, and I'm going to become one with the way this system works, and this is going to be a lot of fun. That's not my mindset. It's a UI. My mindset is really much more pragmatic. It's all about efficiency and utility. And challenge, when I can't get the gesture right, is really not equated with fun. It's really all, it creates frustration. So think about your user's mindset as you create your solutions. Now let's zoom in a little bit more, narrow in a little bit more, and instead of talking about NUI so broadly, let's actually talk about gesture design. Once again, in games, the design for gestures, at least abstractly or conceptually, is a little bit easier. Why? Because if I'm playing soccer and I'm trying to design a soccer system type interaction, if I want the user to kick a ball, I've already got metaphors in place. You can actually ask the user to stand there and swing their leg to kick a ball. If it's tennis, I can ask the users to swing their hands as if they're swinging a tennis racket. There's metaphors that exist, and it's quite direct and it's quite nice. The challenge for UIs are that the tasks that we're asking people to do within the UI are a bit more abstract. And so to find a gesture that actually kind of mentally or logically fits with the user's task is going to be quite hard. So case in point, within the Xbox dashboard, you might be playing a game and now you want to pause that game and you want to get to the Xbox guide. A little bit of an abstract task. Is there a natural metaphor out there for pausing a game and getting to the guide? Well, you might say, well, it could be, a timeout type of a gesture, but that's not necessarily culturally universal. A lot of games might want that gesture. A football game may want that gesture, so we can't take it and call it a standard. So what we did is we found a very innocuous gesture, as you can see, where the user has to stand still with one hand at their side and the other hand held out at a 45-degree angle. Very abstract. It's not discoverable, which means we have to overamp on teaching with lots of instruction and hope that people can remember that particular activity. What you really do want are gestures that are a little bit more meaningful and relate to the task at hand. So excuse the bad art in this particular design, but if you look basically at these two images, what they're trying to tell you is to do a pose, right? If you want to move this menu to the left, stick out your left hand. If you want to move it to the right, stick out your right hand. It fits, right? The semantic nature of what you're asking people to do actually fits with the task. So that's a bit better. And even more meaningful and even better than that would be a menu or an interaction design like this. This is from Dance Central. And they've got a list, and there's a highlight there. And they're doing hand tracking. And so as your right hand moves up, the highlight moves up with you. As the right hand moves down, the highlight moves down. Or if you go even further, the list scrolls depending on whether you go up or down. And then as you move your hand left or right, the highlight tracks with your hand, and that's how you end up selecting items. So it's a little bit more like direct manipulation. In this case, we don't have a literal cursor. We have a highlight, but it's still hand tracking. And that seems to fit with people's expectations of how this should work. All right, so now comes the interactive portion of the presentation. I'm going to stand over here, and through example, I hope to illustrate some of the various design considerations for gesture. So a second ago, we were talking about creating a gesture that fits kind of logically with the task at hand. And so now what we also want as a follow-up to that idea is that when you do design a gesture, we want the UI to actually, the reaction of the UI to fit the user's action as well. So I've got content, I've got a list behind me, and that list extends off screen to the right. And so if I want to move that content from the right to the left, in other words, get it onto the screen, I might have a gesture like this. And in doing so, the list scrolls off-screen content from the right to the left, because I went from right to left. And that makes sense, right? The UI's reaction fit with the gesture that I performed. Now compare that to if I did the same exact gesture, and instead of having the list move, the old content faded out, the new content faded in, the interaction seems broken that way. It just doesn't fit. The UI reaction does not fit the action that I took as a user, and that's what we want to avoid. So now that we say, okay, we think this is a good gesture for moving content or for scrolling a list, now what we want to do is be able to expand and create a gesture set, more than just one gesture. So we want the ability to swipe, as I showed you before, to move content from right to left. But now we want to have an ability to move the content in the opposite direction. So maybe we expand our gesture set to say, if I move my hand in the other direction, the list moves the other way. And then likewise, the same type of swiping motion, I can move my hand up to move content up, move my hand down to move content down. And because all of those 4 gestures involve the same kind of hand swiping motion, we would say that those gestures family up. The idea being that if a user were to discover or learn one gesture, it's probable that they will easily discover the other gestures, because they all family up and they're kind of related. They're very coherent. Now I want to take you to a concept of repeating gestures. So think about the particular gesture you've designed and ask yourself, in a real-world use case scenario, would users like to perform that gesture or need to perform that gesture in a back-to-back fashion? So obviously in this example, we have lists that usually will be quite long, and so in my gesture to move the list, chances are I'm going to have to repeat that gesture, and what you want is a design of the gesture that allows my hand to move in a very fluid manner so that there's no jarring motion, and there are no other activities or things that I need to do in ending one gesture and starting another. I just simply fluidly roll right over, and I can do this gesture in a very fluid kind of a back-to-back style. Now, you're thinking to yourself, you're smart, and you're saying, well, wait a minute, Ali, a second ago, you told us that the gesture of moving your hand from right to left moved content right to left, and the gesture of moving your hand left to right moved content left to right. So if you're doing this gesture in a repeated fashion, you're actually doing 2 gestures in one. And you would be right. It would look something like this. As I move my hand, I'm trying to scroll the list from right to left, but as I return my hand to start the gesture over again, I'm actually doing the other gesture and I'm not getting anywhere. So how do we get the system to pay attention to one part of a gesture and ignore the return motion as you get ready to start the gesture again? And one possible solution, technical solution, might be to say, hey, you know what? I'm going to assign one gesture to one hand and the other gesture to my other hand. So it would look something like this. So with my right hand, I can move content from right to left, and with my left hand, I can move content back the other way. Seems like a good technical solution. It is reliable, it does work, but there is a problem. Users tend to use just one hand. They use their dominant hand. And in doing so, they rarely actually engage their second hand. And beyond that, what you don't want to do is add that level of complexity to your solution where somebody has to actually spend time thinking about, geez, which gesture, in a particular gesture or task that I want to perform, which hand should I be using? So let's avoid assigning specific gestures to specific hands if at all possible. Let's go on to the next thing and say, okay, What about if I want to assign both hands to perform a single gesture? And that's okay. So let's look at an example here. So I've got one hand, and it's still preferred, once again, for you to use one hand for gestures. So I'm going to suggest that you do one hand for critical gestures, like scrolling through a list, and use two-handed gestures, a gesture that involves two hands, for more power user moves, like zooming this list out. So I might do something like that, right? If that two-handed gesture goes undiscovered, it's okay. It's not a critical activity. Users can still use your solution successfully. If you do decide to create those power user moves with two-handed gestures, then make sure the gesture is designed to move so that the user can move their hands in a symmetrical fashion. So for example, if I want to zoom this in and out or move it off screen, those are symmetrical hand movements versus, let's say, this type of movement where each hand is doing something different, very hard for users to do. You don't want to create that level of frustration. Another example for the use of two hands for gestures might be that you might ask your users to target two separate items on screen, one with each hand, in order to do something. And so in this example, I've got two buttons on the screen, and I would use my right hand to target one item, my left hand to target the other item, and in doing so, I've probably lost the first. It's very challenging, very difficult to do. And if you remember what I told you earlier about users' mindsets, in games, so remember Kinect adventures where you've got to plug leaks? It's very challenging to do that, but it's fun because you're in a game, and that challenge is what makes it fun. In a UI, if you're asking people to use two hands and target two different items simultaneously, that challenge is not going to be interpreted as fun. It's going to lead to frustration. So avoid that. Now let's talk about gesture payoff. So we showed you some two-handed gestures. Now imagine, for example, if I was doing a two-handed gesture to move some content on screen, I did something like this. Two hands, swiping, and all I got was one item on the screen. It seems like a lot of work with a little payoff. If you're going to use two-handed gestures that require the user to exert more effort, then give them a payoff. So do something like this to move them all the way to the end of a list. A little bit more effort on my part, but the payoff was worth it. And so this brings us to one of our final points for gesture design consideration, and that is fatigue. If you've got a super long list or an activity that's going to require a lot of repeated motion, just remember that eventually people will get tired, and being tired is the best way to kill the enjoyment of a gesture-based interaction. Users are not going to sit here forever to do this to get all the way to the end of a list. And you could say, well, Ali, how about not moving your hand as much? What about if you just stuck your hand out and the list continued to move? Yeah, that could work too, but the problem is still holding my arm up, large motor muscle movement. I'm going to get fatigued and I'm going to get messy and I'm going to get frustrated. Not a good thing to do. Perhaps the better thing as an alternative might have been, with one gesture, I could set the list in motion, momentum takes over, maybe there's no friction, so it'll just keep going at a reasonable pace, and then all I have to do is apply the brakes to stop it. There's probably a half dozen different ideas. But just keep that fatigue in mind. And lastly, but not least, when you do design a gesture for a user to use in accomplishing a task, make sure that that gesture can be performed in all the various postures and poses that you expect your users to be in. Whether that's lying down, sitting, or standing, make sure that that same gesture works equally well in all three positions. Please avoid designing a gesture that works really well standing but poorly when sitting, and avoid designing a gesture for standing and a different gesture for sitting if they're both going to accomplish the same task. One gesture that works equally well in all postures, that's ideal. So we've covered a lot of various kind of guidelines or some considerations when it comes to the design of a gesture. And let's say in going through those types of exercise, as you think about the various items we talked about, you've narrowed in your gesture ideas. And now you're ready to go into the prototyping phase, and that takes us into the second part of our talk here, prototyping and research. I have to thank my friends in user research, Eric Pennington, John Davis, for supplying this material for us. and I'm going to do my best to represent them and their material. So this is about prototyping and research. And when you're designing for Kinect, it's unlike anything you've ever designed before, any other type of input and interaction. There's a lot of new things to take into account and consider that you may not have had to do previously. With Kinect, there's a lot of physical variables. You have to imagine that you're now looking at the entire person, whether that be an adult or a child, whether you're looking at hand and arm movements or entire body movements. A lot of things to be looking at there. You have to also imagine what it's going to be like for that person and to be in a certain environment. Are you asking them to move around a lot? Are they going to have the space to do that kind of movement? Is there furniture that they're going to have to move out of the way? A lot more things to take into account. What are the person's expectations, and certainly what are their experiences that they bring to kind of drive those expectations when they're ready to use your solution? Here's an example of what I mean by that. So you're about to see two kids that were brought into one of our labs, and there was no UI for them to look at. There was just a target on a screen, and they were asked to kind of mime or perform some gestures as if they were shooting this particular target using a pistol and using a rifle. So here's two different kids with two totally different set of experiences and expectations when it came to using a gesture to fire that target. So we're asking this person to use a rifle, and she's doing something that kind of looks like playing a violin. And here she is using a pistol, kind of like a whip actually. But here's a young man who has recoil when he fires, and when it comes to a rifle, he actually loads around, fires, and has a little bit of recoil. So certainly their life experiences, I'm sure he's played a lot of Xbox games, comes to bear on the type of gesture that they're going to perform. Now our challenge, of course, is in dealing with all of that variability, different people trying to perform the same gesture in different ways. So as Arturo kind of talked about earlier when it came to, pushing a mouse click, and we all did the wave example, recognizing intent is a very, very tough challenge for us. Did the user really mean to perform that gesture or a different gesture, or were they just simply moving their body as they were having a conversation with someone else? Here's an example of a video where we've got a UI, and we got these two green lines here, and when the user's hand or cursor enters anywhere between these two lines, they are now connected to this list, and as they move their hand, the list is going to move with them. And you're about to see this lady try to find a Lady Gaga slot and bring it into focus, and watch what she does. So her hand is in there, and every time she moves her hand in there, she moves her hand back and the list goes the other way. And so she starts to develop this strategy of, okay, I got to move my hand into the area and then out of the area. So she's got a circular motion going on here. Now she's getting a little bit more elaborate because things are not quite working the way she wants. She gets in there, she moves it a little bit, and she moves out of it with big gestures and big intention. She's really close now. She's almost got that Lady Gaga slot there. And to avoid any further interaction, she kind of slyly moves her hand behind her so that the camera doesn't see her. Not a great experience, obviously. So recognizing intent is a key thing here. If we do that successfully, then we have gesture reliability. And what we really mean by that through these examples is that you're going to see a host of different people actually performing this gesture that I've been doing all along to move content off screen onto screen. But you'll notice that they're all doing it differently, and yet we designed the system so that all of these would be successful. You can see the amount of variability in the style of their gesture, but our system was designed to be robust enough to actually accommodate all of those different gestures. All of those people would have been successful. So reliability is really a two-part formula. It's constraining what you're looking for so that you're not accidentally moving your body around and activating a gesture, but being flexible enough so that you get all of those people being successful with their own little nuances in terms of how they do it. So finding that balance between constraint and flexibility is going to be key in your prototyping efforts. So obviously prototyping is a big part of kind of refining and dialing in that reliability. When you do go to create the prototype, we would say all hands on deck. So get your developer, get your designer, get as many different people, as stakeholders as possible there at the time that you're doing it, because they're all going to contribute across the board. So when it comes time to coding, you need to know about, have the designer there to talk about affordances and feedback. And in understanding how it's coded, we might be able to tell the developers, hey, these are the types of parameters we want to be able to tweak so we can refine the gesture. Obviously, test with actual users. That's going to be key. You're going to do your own testing with just yourself and the team, but obviously take it into real environments and with real users, and there's no substitute for that. And have some success criteria for yourself. So as you set out to create these gestures and these prototypes, don't try to evaluate the success or failure of it after the fact. Set up some success criteria for yourself ahead of time. Like, how quickly would you want somebody to learn a particular gesture or perform it? What about accuracy? Like, how many errors are tolerable, if any? In doing the gesture, would users prefer to do it with a gesture and performing a particular task, or would they abandon gestures and go to some other form of input? And lastly, when it comes to gestures, how discoverable is it? Can they discover it within the first 5 seconds or 10 seconds? How long is it going to take? So set some criteria for yourself, and then as you build and prototype and test, you'll be able to see whether you've met that criteria ahead of time. This is just a reminder for me to tell you we had great success in building internal tools for ourselves that allowed us to tweak various parameters of a gesture. So in real time, we could say, hey, you know what? What if it was faster? Or what if we looked for a faster movement or a bigger movement? It was invaluable to be able to tweak things in real time. And if you can do that for yourself, I think you'll find the value as well. So that's it. We've covered a lot of ground here. And I'll invite Arturo back in.
Thank you, Ali. That was amazing. And thank you very much, everyone, for being here in this session. We are going to be welcoming all your questions. There is my Twitter account on the bottom, @ArturoT. So if you have any questions, I'll make sure that myself or Ali can reply to you. Also, check out this book, Brave New World. It's something that I recommend you guys take a look at to learn more about touch. There's a lot of touch gestures. There's a particular chapter that talks a little bit more about air gestures. And thank you very much for being here, and we'll keep in touch.
Thank you.
Thank you.